Hello, and welcome to Science with Mr. Morgan. In today's episode, we are going to talk about matter, mass, and volume. First up, let's look at matter. What is it? Essentially, it's just all of the stuff that exists in the universe around us. Everything you can see, everything you can touch, it's all made of matter. Yes, even you are made of matter. Now, all matter has both mass and volume. Since matter has mass, what is it? All it is the measure of the amount of matter in a substance or an object. Wait a second. Mr. Morgan, what does that even mean? Basically, all it means is that matter has mass because mass is the measurement of how much matter is present. Now, I know that sounds convoluted, but the big takeaway from this is that they're closely related. Matter and mass are closely related. Anyways, remember how we talked about scientific units in the scientific method and SI units episode? The basic SI unit for mass is the kilogram, which is represented with lowercase k, lowercase g. So how is matter measured? It's measured using a balance. These can be triple beam balances, electronic balances, mechanical balances, as well as others. When using a balance, if both sides of the balance are level, the items have the same mass. If one side of the balance is lower than the other, the side that is lower has more mass on it. If one side of the balance is higher than the other, the side that is higher has less mass on it. Let's apply it to an example. We'll use this question here. Which has more mass, the fruit or the iron? If you said the iron, you'd be correct. Notice that the side with the iron is lower than the side with the fruit. Now, continuing our conversation with matter and mass, we should also talk about weight. Sometimes weight and mass are used interchangeably. However, that's not quite accurate. So weight is different than mass, but how? Mass is a measure of how much matter is in an object, whereas weight measures the force of gravity acting on an object. If the strength of gravity is constant, like it is on Earth, then an object's mass is directly proportional to the object's weight. Objects that have greater mass have greater weight, at least in this case. And this is where the two get mixed up. And it all is because gravity is constant on Earth. If it wasn't, mass and weight would not get mixed up as much, because they would really be different. Let's take a look at this mathematically. With Earth's gravity, an object with a mass of 1 kilogram has a weight of 2.2 pounds. So how much does a 10 kilogram object weigh when it's on Earth? Well, if a 1 kilogram object is equal to 2.2 pounds, we can use that proportional relationship to answer this question. To do this, we can multiply 2.2 pounds by 10 kilogram, which equals 22 pounds. So this means that a 10 kilogram object on Earth weighs 22 pounds. Now that's enough about mass for the time being. Let's take a look at volume now instead. So first up, what is volume? By definition, it is a measure of the amount of space that a substance or an object takes up. Just like mass has a basic SI unit, so does volume. And the basic SI unit of volume is the cubic meter, which is represented by a lowercase m raised to the third power. Liquids can be a little different though. They can be measured in liters, represented with a capital L, or milliliters, represented with lowercase m capital L, instead. Now, just like we talked about measuring mass, we're going to talk about measuring volume. How the volume is measured depends on its state, and I don't mean state like Pennsylvania or New York. I mean its phase state. The volume of a liquid is measured using a graduated cylinder or a measuring cup. The volume of a gas is dependent upon the volume of its container. And this is because gases expand to fill whatever space is available to them. The volume of a regularly shaped solid is calculated from its dimensions. For example, the volume of a rectangle is calculated by multiplying width times length times height. The volume of an irregularly shaped solid, however, is measured using the displacement method. So what is the displacement method? Essentially, it is when you have a known amount of liquid, and typically water is used for this. And this liquid is in a graduated cylinder or some type of measuring cup. The irregularly shaped solid is placed directly into this liquid, and the amount that the liquid is displaced is used to determine the volume. This is done by taking the end number of volume that you got and subtracting the beginning volume that you had. Now, we're going to put this into action with this example. What is the volume of the dinosaur in the slide next to me? First, let's look at the original volume. In the image, we can see that there are 4.8 milliliters of water in the graduated cylinder. After we add the irregularly shaped solid, aka the dinosaur, the water rises to 5.6 milliliters. If we take 5.6 milliliters and subtract out the 4.8 milliliters that we originally had, we get the end result of 0.8 milliliters. So, even though the dinosaur is not a liquid, with the displacement method we use liquids, so the volume of the irregularly shaped solid, the volume of the dinosaur, is 0.8 milliliters. And that brings us to the end of today's lesson. Until next time.